Good morning, students. In the previous video session, we have discussed about the variation of G with depth, variation of G with altitude, and variation of G with latitude also. And your half-yearly exams over. We are now going through our correction. I believe that you all did well. And today we are going to have a new session, new topic, that is what escape speed. So escape speed means what? Assume that you are throwing one stone upward. Just you are throwing one stone upward. You have thrown a stone upward. For a certain height, this stone will come back to the earth surface. It will fall. Now you are throwing this stone with little more force, and now the height of the stone range is little increased. Again this stone fall back down. Now you are throwing the stone with more force and with more height. You couldn't see the stone came back to you. So this is what we are saying. It is escaped from this gravitational field or gravitational force. Like that, you know this thing. In our universe, in this universe, hydrogen and helium is the most abundant material. But in the Earth's surface, this hydrogen and helium presence is less when we compare to the nitrogen and the oxygen. What is the reason? In the universe, this hydrogen and helium is mostly abundant, but what is the reason why this hydrogen and helium amount is less in the Earth's surface? This is the reason. That is what we are going to study about now, escape speed. We know this thing, this hydrogen and helium is very lighter molecule, lighter nuclei. So what will happen means, in some certain speed, within some speed, this hydrogen and the helium is escaping. So hydrogen and helium need some speed, a very small speed is enough for them to escape from this gravitational force. That's what this amount of hydrogen and helium is less in the Earth's surface, and nitrogen and oxygen is mostly we can see in the Earth's surface. So you can consider a mass of an object of M. One mass of an object M. You are throwing this object upward. So the initial kinetic energy, initial potential energy will be there, because you are throwing an object which has a mass M, you are throwing it upward. So when it is moving upward, it possesses some kinetic energy and it possesses some potential energy. So that is what kinetic energy, what initial kinetic energy you can write half M V square. Vi you can write because initial kinetic energy. Potential energy also you can write initial potential energy minus G M mass of the earth M by R V square. So this is what our kinetic energy and the potential energy minus G M E by R E. Now when we are throwing this object of the mass M upward, it has some total energy. So that total energy we have to find out. That total energy, how we can find out means just adding this kinetic energy and the potential energy. So total energy you can tell EI, initial total energy. So you can add this kinetic energy plus potential energy. So total energy EI is equal to kinetic energy half mvi square plus minus plus into minus root of g m e by r. This you can keep equation 1. This is the total energy. It has water. When you are throwing an object upward, the total energy you will get is half mv square minus gmme by ra. Now assume that you are throwing this object far from our height, that is what you can keep it as infinity. So it is at some place, so we can keep it as infinity. So at this position, the kinetic energy is 0 and potential energy also 0. So at infinity means what? Somewhere at infinity, this kinetic energy and potential energy is 0. If the kinetic energy and potential energy is 0, so what will be the total energy? What will be the total final energy? This is the initial energy. So final energy, final kinetic energy, final potential energy 0 means the final energy also will get what? 0. So you can get EF is equal to 0. This is total final energy. Now according to law of conservation of energy, energy cannot be made or destroyed. It can be changed from one to another. It can be changed from one form of energy to another form of energy. So there is some initial energy. This is the initial energy, but final energy you got 0. So what happened means, according to law of conservation of energy, initial energy is equal to what? Final energy. It should be what? Initial energy should be equal to final energy. So initial energy is equal to final energy. This is what? According to law of conservation of energy, initial energy should be equal to what? Final energy. Now, what you can do is, you can substitute this what? EF is 0. EF is 0 means, and EA is what? EA is this one. So substitute equation 1 in equation 2. While substitute, what we will get? EI instead of EA, what? Half mvi square minus gmme by re is equal to EF. EF means what? EF is 0. Now half mv, here you can change this I as E. Now we are considering this speed as escape speed. We are considering this speed as what? Escape speed. So v square is equal to gmme by r. Just take this what? This minus this after equal symbol, so it becomes plus. Now this m cancel. Half v square is equal to GME by RE. Now V square is equal to this 2 will go here, so GME by RE. Now we know that G or gravitational force, G gravitational is what? Formula is GME by RE square. So this is our formula, gravitational potential energy. So, sorry, not gravitational potential energy, gravitational field formula GME by RE square. Now what we can do is, here RE is there, G is there. G is there, ME is there, RE is there. So we need one more RE to change these quantities as G. So what you can do is, this you can keep equation 3, equation multiply and divided RE in equation 3. In equation 3, you have to multiply and divided by RE. So what will come? VE square equal to 2GME by RE into multiplied by RE divided by RE. Now VE square is equal to 2GME RE by RE square. RE into RE square. Now GME by RE square, this we can take as what are G. So VE square is equal to 2G RE by R by already taken 2GAR. So V escape speed is equal to root 2GR. This is what our equation. Escape speed. This escape speed is depending upon the gravitational force G, and it depends upon the radius of the earth. We know the gravitational force value G is equal to 9.8 meter per second, and the radius of the earth RE is equal to 6,400 kilometers. So when you are substituting these values in this equation, you will get the escape speed 11.2 kilometers per second. So this 11.2 kilometers per second is very so this speed is enough for this hydrogen and helium to escape from the Earth's surface when we compare to the nitrogen and the oxygen. This is what one of the important, very important question in this unit, 16 unit, 5-mark derivation, escape speed. So we are finding the escape speed of the object from the Earth's surface. For that, assuming an object you are throwing upward, after throwing this object upward, it possesses some kinetic energy and potential energy. That kinetic energy is half of V square, and the potential energy is minus GMME by RE. So if you are finding the initial total energy, when you are throwing this, some initial will be there. After reaching somewhere, some final energy will be there. So this initial energy EA is equal to the total kinetic energy and the potential energy. So while adding this kinetic energy and potential energy, we will get half mv square minus GMME by RE. And now assuming that you are throwing the object very far, it is what some infinity. You have to keep it as some infinity. There the kinetic energy and potential energy is zero, so the total final energy also zero. So EF you can take it as zero. But according to law of conservation of energy, what are? Energy cannot be destroyed. Energy can be changed from one form to another form. So there is some initial energy, there must be some final energy. So both are equal. So you can take EA is equal to EF. Now you can substitute this equation 1 in equation 2. Instead of this EA you substitute this, and instead of EF 0. Now after substitution you can take this quantity of this equal symbol, so you can cancel this m and m. So half E square is equal to G m by Re. From here you have to take these two upside, so V square is equal to 2G m by Re. You will get up. Now we know that our gravitation force G is equal to G m by Re square. So we have to bring here Re square. So you can take this G m by Re square as G. For that we are multiplying and dividing Re in this equation. So we are multiplying Re. We will get 2G m Re by Re square. So here G m by Re square we have taken as G. So we will get V square is equal to 2G Re. So V is equal to root 2G Re. So we got the escape speed formula. So this escape speed is depending upon the G, gravitational force, and the Re, radius of the earth. So we know the value of G is equal to 9.8 meter per second, and Re is equal to 6400 kilometer. When we substitute this value in this equation, we will get the escape speed 11.2 kilometer per second. So this hydrogen and helium is a lighter material, so it is enough. This speed is enough to escape from this gravitational field. So this is what the escape speed equation. Now orbital speed. That is next topic. Orbital speed. We know that this escape speed is one of the very important 5-mark questions. You have to practice. Last year exam also they asked this question, and give more importance to this escape speed question. You have to practice 2 or 3 times, and this is your homework for you. Tomorrow you have to complete this homework, take your notebook and try to derive this equation. If you have any doubt, you can ask in the interactive session. Now next one is about the orbital speed, satellite orbital speed and time period. You know, here on orbital speed small equation is there. Orbital speed. Assume that this is the earth and center of the earth. This is the radius of the earth, and from this height on satellite is rotating. Satellite. This is satellite, and this is the height where the satellite rotates. So what is the radius now? Re plus h. Now the total radius is Re plus h. From the center of the earth, some height the satellite is moving. You know that in this modern world, this satellite, because of this satellite, we have so many use. Now you know that some people will not sleep without their mobile phones. Some people will not sleep without using the internet. So, in this modern world, the satellite is one of the important part in each and everyone's life. It becomes now. So, you know that satellite which is moving, revolving Earth like the planet which is moving around our Earth. So from the Earth surface, some height the satellite is rotating around the Earth, and for that some height we can keep it as h. Now you can consider on satellite of mass m which is moving, revolving around this Earth surface. If a satellite is moving, revolving around the Earth surface, means surely it needs a centripetal force. Any object which is moving, revolving around in a circular path, it needs a centripetal force. So around the Earth surface, this satellite is revolving, means this satellite revolving means what? It has some centripetal force. It has some centripetal force. From where did this centripetal force came? This centripetal force is this much. We know that centripetal force is mv square by r. R means here radius of the Earth, so you can keep mv square by r. This is what radius. Here what r? Radius from the satellite is r e plus h. So this is a centripetal force, and from where did this centripetal force came? Means this centripetal force is provided by the gravitational force. G is equal to Gm ma by r. So this is a force. Now what you can do is, so now you can find out the total force. You see, this centripetal force is provided by this gravitational force. So you can write this formula mv square by re plus h. Here also, instead of this re, what you can use? G m e by re plus h the whole square. Now you see, this centripetal force mv square by r is provided by this gravitational force. So this gravitational force is equal to the centripetal force. So mv square by r e plus h is equal to g m e by r e plus h the whole square. Now m cancel, r e plus h, one r e plus h is cancelled, here 2 are there. So v square is equal to g m e by r e plus h. This is the, now v is equal to root g m e by r e plus. So this is what the orbital speed of a satellite. So how you are finding this? This is one small 3-mark question. Orbital finding. Assume that one object, the satellite which is revolving around the Earth surface. When this satellite revolving around the Earth surface, it has some centripetal force to revolve, and this centripetal force is provided by the gravitational force, and the centripetal force we know that mv square by r. So here r means what? The radius means this much distance. Re plus h. It's what here Re plus h. Now this centripetal force is provided by the gravitational force. G is equal to Gm e by Re square. Here also instead of Re plus h. Now Centripetal force is provided by the gravitational force, so both forces are equal. That's what mv square by r is equal to g we are taking. So mv square by r plus h is equal to gmme by r plus h. Now m and m cancel, r plus h, here one r plus h cancel, remaining v square. Then here gme by re plus h is remaining. So v is equal to what will come? Root of gme by re plus h. So this is what the orbital speed and my dear students, you can go through this derivation escape speed and orbital speed. This escape speed is one really important 5 mark question. And this one is 3 mark question. You can check in the page number 22 and 23. From the page number, you can mark consider an object of mass m on the surface of the earth. Second paragraph, no need of first paragraph. You can page number 22. You can mark it from the second paragraph. Consider an object of mass m on the surface of the earth when it is thrown up with initial speed. From there, you can mark until 6.56, and in the last paragraph, you have to mention this escape speed depending on 2 factors, acceleration and radius, and just a small calculation is there. And from the last paragraph, lighter molecules such as hydrogen and helium have enough speed to escape from the earth, unlike the heavier ones such as nitrogen and oxygen. This last paragraph is one 2 mark question also. In on exam they asked a conceptual question. So this is the answer. You have to learn this point also. Lighter molecules such as hydrogen and helium have enough speed to escape from the earth, unlike the heavier ones such as nitrogen and oxygen. Then next page number 23. Page number 24, orbital speed. Page number 24, for a satellite of mass m moving in circular orbit, centripetal force. Then from there until equation 6.58, the last as height increases, the speed of the satellite decreases. Until that, you have to mark it and practice it. Thank you all. Bye bye. See you.